So it's been a while since we last spoke, and today I thought maybe we could have a little bit of a break from the cloud programming, mobile app development world and do a little bit of data analysis. Given the fact that it's the NBA playoffs and we've been seeing some great games, I started to think, well, how many points is it possible to actually score in an NBA game? And that's a loaded question, right? Because based on the NBA rulebook, and I'll put the links in the description for you to take a look at yourself. The answer to that question is actually infinity, right? You can an NBA game can go on for the rest of human existence for the most part, not at least until all the players pass on, I guess, without without being stopped and without a second actually going off the shot clock because of fouls and points that can be accrued while the clock is not running, right? So technical fouls, dead balls, stoppage of time, you name it, all those things can happen and they actually lend themselves to the overall score. So you could have an NBA game 1,000 to 1,000 and the game actually quote unquote hasn't started, right? Well, it started, it must have started, but basically the points are being accrued without the clock moving. So we're going to disqualify that. And for this thought experiment, we're going to be doing some analytics to figure out, well, what's the best way, what's the best strategy to score the most points in an NBA game with a couple of caveats and a couple of rules in place. First of all, both teams have to be collaborating together, right? So in this fantasy world that we're creating, I want you to imagine, I don't know if you've ever seen this movie, it's a great movie, it's called Pleasantville. And in it, basically, the basketball players, they make every single shot they take because everything is perfect, right? So, um, so, so imagine that team. Imagine a team that has players, no players ever miss, right? They make every single shot because again, we're dealing with the theoretical here. So they make every single shot. Let's put that down there, right? So they make all shots. So they're all shooting at 100%. Whether it's a three-pointer, whether it's a two-pointer, it doesn't matter, right? And of course, as we said, we're not doing anything related to dead balls, right? So no dead ball fouls. And these are just rules that we have to put in place for this to make sense, right? Right. And you can actually go on and we're going to be using the official NBA rules, right? And in the official NBA rules, the game, there's no disqualifications after you get to 5 players or 10 players on the field, right? So no disqualification after 10 players are left. Okay, we're not doing anything with injuries, we're not doing anything like that, and we're going to be using the Trent Tucker rule. So Trent Tucker, this is an NBA rule that determines how long it takes for you to actually put up a shot, right? How long you can have the ball in your possession and put up a shot, right? So for tips, it is 0.1 second, okay? And for catch and shoot scenarios, it is 0.3 seconds, okay? That being said, there is a cost associated with putting up a shot, right? So for tips, we'll say that the cost is 0, right? So you might imagine a player inbounds the ball, throws it directly 94 feet at the other basketball hoop, and that the individual over there literally just guides the ball in from the side, just touches the ball, right? So just touching the ball and the ball goes in, that is going to cost you um, zero point 0.1 seconds. For catch and shoot scenarios, the further away you are from the basket, basically there's going to be a cost associated with it, because the way the NBA rules work, it's not full on time dilation, meaning that literally you have to be touching the ball, or the ball has to be in your possession for the clock to move. When you shoot, you're actually within the game, right? So a 3-pointer, we'll say, takes 2 seconds to go in, okay? And we'll say that 2-pointers, so medium range shots, we'll give them 1 second. And of course, tip ins like that, so which are also 2-pointers, but at 2-point tip ins, right, is 0 seconds as stated, okay? So these are the basic rules of operation in case you at home want to build your own algorithm and attempt to figure out what the best approach is here. Ensure that you're following these basic steps, okay? And then the final piece of the puzzle is basically how many points can be scored in one possession after how many extra points can be scored on a possession after the actual a score has happened. So if you shoot a 3-pointer, what's the maximum number of points that can be scored after you shoot a 3-pointer? So max points during dead ball. And for this, we're gonna say that it's 2 points, right? So basically, for all possessions, it would be an and one, right? So you get 1 point per possession because the teams are collaborating. So they're gonna soft foul you with an and one, whether it's a 3-pointer, 2-pointer, whatever. And then there will also be an unsportsmanlike conduct foul that happens as well, which would lend itself to a technical foul. Right. So altogether, for every single score that you make, for every single possession where you score, you're gonna have 2 extra points. 1 for the and one foul and 1 for the technical foul. Additionally, we want to set a cap on this +2 number over here, right? So we want to set a cap on this +2 number. Just want to make sure we highlight that. And the reason we're setting that cap is that, again, if we start going into dead ball fouls and things of that nature, the answer is obvious. The answer is infinity, right? The answer is as long as it takes for the players to literally drop dead, right? And then that would be too many variables. We'd have to start looking at their their health risks, their eating habits. I mean, and I jest when I say that. Let's just keep it out of it to make the thought experiment clean, right? So we'll say that as a whole, you can only add 2 points to everything. You get your technical foul, and you get your additional foul associated with the point, right? So the other thing that we also need to talk about is what happens when players start to foul out, right? What happens when players start to foul out? Well, and how many players are on an NBA team, right? So we're going to be going with a 15-player roster. Okay. And again, we're going with the NBA rules. It's Rule 3, Section 1B. which basically states that when a player has fouled out, and if you only have 5 players, a technical foul is issued to you if that additional player commits a foul, right? So once again, that lends itself, right? Player fouls, that lends itself to this number right here. And again, we're going to cap it at 2 points that you can get, right? 2 points that you can get for every single possession, right? And we're not going to include technical fouls in the overall flow of the game. So what do I mean by that, right? So let's say no technical fouls, right? No techs, right? So I know I said up here that the maximum is 2 because of and 1 and a technical foul. But for the purposes of the exercise and to remove technical fouls and the dead ball foul scenario from the equation, we're going to say that the only technical fouls that can be committed are technical fouls associated with players essentially committing fouls when when they have no more fouls to give, which by the way happened, I think, in 2010, Golden State versus the Blazers, right? So this is that, it seems it's improbable, but this has actually happened before, right? So we're gonna say no techs. That's a big one, right? No technical fouls other than technical fouls that are tied to a player elimination or player disqualification, right? Player disqualification fouls. Okay. So what this ultimately means is that for a period of time, you're going to be scoring points and it's just going to be an and one. And then for a period of time, you'll be scoring points and it'll be an and one plus a technical foul for the penalty of having the player basically basically have almost fouled out, right? And when you run your calculations, and my calculations, I'm going to be using a certain kind of strategy. But if you're to do it and you're to run your calculations, you're free to work within these rules as you see fit in order to build the algorithm that you think makes sense and beats my score, basically. All right. So what are the rules that I'm going to implement? So my rules, how am I going to build this out, right? So my rules, okay? So rule number 1 is that I'm going to commit all my fouls across both teams as fast as possible and with as little possessions, minimize the number of possessions that I have, right? So commit fouls immediately. To get to max, okay? So that's number 1. So in my game, within 13 seconds of the game starting, there should be, or around 13 seconds, depending on whether or not on the scenario you're taking, whether you're shooting 3-pointers, 2-pointers, catch and shoot and all that. But within a short amount of time, basically, I'm going to have all my players commit all the fouls that they need to commit in order for for me to max out on the personal fouls and get as fast as possible to that to that technical foul boundary, right? That's number 1. Number 2, I'm going to be analyzing 2-pointers, 2-pointer tip-ins versus 3-pointer catch and shoot versus medium range 2-pointers. Okay. And I'm not going to add any percentages into it. okay, at this point in time. So we're not going to increase the likelihood one way or the other because it's all improbable and everybody makes everything, right? But just to see, well, what's the difference, right? And my contention is that in this scenario, in this kind of way that it's set up, the games becomes less about points, individual points, and more about possessions, right? Which is an obvious statement to make because they're shooting at 100% of the time. And as we evolve this algorithm, we can start increasing, we can start looking at the percentages and seeing how those percentages affect this dynamic of possession versus points, right? And I'm going to be building this in C sharp, okay? But you're welcome to build it in Python or whatever language of your choice, okay? Now, even though I'm going to be building it in C sharp, because these kinds of data analytics and quant work are typically done in Python, or a lot of people do it in Python, I'm going to kind of make it look like Python. So if you're a Python programmer, it should look somewhat recognizable to you. The real difference is the is the brackets, right? And the variable types, right? So C# has variable types. Python does not have variable types. It has casting that you can do to cast a value to the type that you want to use, right? And the brackets, basically C# is a bracket programming language. Python uses spaces, white space, to basically create the language structure. So those things I will not be able to change, but the things that I can change for this basic application, the things I can make look like Python, I will make look like Python. Okay. So having said that, let's get going. Let's build it out. All right, now let's get going. So I've got my program set up, started Visual Studio 2022 preview. I've created my MBA Quantify project. It's a console application. And I'm gonna enable some things here. So I've enabled language version preview. It doesn't matter. I just typically do that. And I usually disable the nullable reference types just to get this going. And so first couple of things I'm going to be doing is I'm going to be creating some basic functions that emulate what Python has. So the first one is print. Okay. And print essentially will take a string, label, and an object data. Okay. Right, so let's go ahead and let's get rid of all this because we don't need it. And I'm just going to build that to make sure we are good. Okay, so there's no main method, which is fine. And we're going to create a print function. And I'm actually going to use a technique in C# which allows you to take a namespace or a class and treat it like, put it in scope so that you don't have to keep using the individual naming scopes. Like you don't have to, if it's a class is console in this case, or if it's a static class, I can just use the methods. I don't have to actually use console. So it's like a way of aliasing it, right? So I'm gonna using there we go. So that took a second. So then in here, I can basically just do right line, right? I no longer have to keep typing console the whole time. And label plus, let's go ahead and let's pass an object. Right? So then I can go over here and I can say print is, age is, right? And when I run this, you should see your age is 22, right? So now that we have that, I'm actually going to change this a bit. Just going here and just clean it up just a little bit. And I'll actually add the colon so that you don't have to keep adding it. Right. So and let's run that. And there we go. So it added properly. And I don't want to keep on doing this. So I'm going to see if I can pin it here. There we go. And move this over. It's cool new Windows 11 stuff. There you go. And I don't think I even need that. So I'm going to minimize that so I can give myself a little bit more space. There you go. So hopefully that's easier for you to see. All right. So the other function that Python has that we're going to be using is the input function. Same thing, void input. And this will also take a label. But in this case, it does not take any other variable. And it actually will return a T. Okay. Right. So we can specify what we want to come back from it. And we're going to be doing a read line. And then we're just going to be casting that to T. Hopefully that works. Let's make this an object. There we go. And then let's do an example here. So input int. Okay, age. Okay, and then we just print out the age. Okay. So on that, oopsie, forgot one thing here. So read. All right. There we go. So what is your age? I'm gonna say 54. And honestly, this strategy will likely not work because in certain instances, like for example, converting from a string, which is what's going to be coming into an int, we just don't know um, what that conversion is going to look like. So we would have to do that conversion. Trying to do it like this is just not going to work. We'd have to do that conversion ourselves on our end. So I'm actually going to simplify this, get rid of that, turn this back into a string. And then when I read the line, I'm just going to return that, make this a var, right? So this way we get our input, okay? And then if we want to convert that in this case, in the parse, this gives me essentially functionally the same thing, right? So if I run this now, what is my age? 40, 400, right? Your age is 400, it just returns back the number. So those are the two things that we're going to be doing as part of just the foundational work to get this going. So now that we have that and we're on the move, let's get into the actual algorithm itself, right? So first of all, we're going to be making multiple comparisons, looking at different things. So we definitely want some kind of loop, right? That we can use to determine the program flow, when to end it, right? And then within that loop, we want to get the time needed to score, okay? And then we also need to get the cost, right? Well, that is the cost. We also need to get the value, sorry, okay. Score, right? So those are two things we need to capture. So we're gonna loop through, get the time needed to score, get the value for each score, right? Then what else are we gonna do? Then we need to calculate the total number of possessions. We need to know that. Calculate the total number of fouls. These are all constants. They're not going to change at any point in time. It's basically going to be the same regardless, but we're going to calculate that. So we're going to then now calculate points scored during the standard fouling period. So as stated from the previous time, that's there's going to be points scored where you're just getting and ones, because we're not going to, the only technicals that can be added to the points are technicals that are completely unavoidable, because we've basically run out of players and we're down to 10 players, right? So there's going to be a period of time where you're not getting those technical fouls, and then we then calculate points scored during the loophole period, right? So this is a loophole because we're getting extra points from the one technical foul. And then we just need to add those up, and that's the final result and display results, right? Right. So fairly straightforward. Okay. So how are we going to do the looping, right? So let's use, there's two variables that we're getting in, right? We're getting the time needed to score and the value of each point. Let's use the time needed to score, right? So I'll call it the cost per score equals to 0. Okay. And this is gonna be this has to be a floating point value. Oops, this has to be a floating point value. So make it a float. Okay. But even though it's a float, use the old school do while. Oopsie, what am I doing? There we go. So while the cost per score is greater than 0, we're gonna do all these things that we need to do. So I'm gonna put out all this in here. And if the cost per score is less than 0, then basically we will so I'm using greater than equal so it can go in the first time. So I'm going to just print out okay. And over here, let's change it because we want the ability to print. Sometimes we're going to be printing things out that have a value. Sometimes we're just printing things out to say that it's done. So how you do that in C# is that you're going to make this nullable. And then I'm just going to do this not equal to null. Else, we just print it normally. So if you're a Python programmer, you can already see why for basic stuff like this, C# is just not, it just doesn't make any sense, right? It's just so verbose. Like everything I'm doing here, all of this is unnecessary. These are just built into Python. And by the way, like even something like this, I would still have to sort of like create this structure. These are built into Python by itself. And I'm sure there's libraries in C# that give you the same capability, right? But just in general, right? So we should be able to test this right now. But first of all, we are going to have to get the cost per score. Okay, so cost and time per score. And of course, this needs to be converted into a float. There we go. And so we're going to go in and it's going to check the cost per score. And then when it checks the cost per score, if it's 0, the next time it comes out, it'll go out and be done. So let's run this. And if I enter 5, 4, 3, 2, 1, 0, -1, and we're all done, right? So it should be straightforward what's happening there. And then the next is to get the value for each score, right? So the value for each score, right? So it's called points per score, right? And the points per score would essentially be the same thing. And this time it's in integers, right? Parse, right? And in here, we're going to do an input. And in here, we're going to say okay. And honestly, I don't like how close this is. So I'm going to give myself a little buffer here with the input as well. Okay. So we now have the value per score, the points per score. And then let's just do some basic uh, legwork, right? Even before we get the points per score, there are some things that we need to calculate, right? So, and we can make these constants, right? Because they basically don't change, right? So minutes per quarter. That's 12, right? And NBA quarters. And we all know the answer to that. That's 4. Okay. Number of teams, we all know that's 2. And obviously these can be put in and just plugged in, but good programming practices, just label them so that you can reuse them. And not that they're ever going to change, but right? Why not? Right? Makes it more readable. Makes people understand explicitly what you mean when you use a value, right? So number of active players. 15. So we're going with 15 for the number of active players. Right. So the number of playing per team is 5, right? So the active players on the roster, right? So maybe I shouldn't call it, we're gonna call it roster. Roster players, playing per team, and of course, number of fouls equals 6. Okay. So these are the basic things. They're not going to change. It's just, it is what it is, right? So giving these numbers, we should be able to calculate some things up here. And these will also not change. They're not variable. They're basically not going to change. So the next one would be, the total number of minutes. And that's obviously the minutes per quarter times NBA quarters, right? That's easy enough, right? Total seconds is total minutes times 60, right? Number of seconds in a minute. And then the total possessions based on that. Okay, so this is going to be our first calculation right here. Yeah, so what we're going to have to do here, so to figure out the possessions, we're going to take the total number of seconds and we're going to basically divide it by the cost per second for for us to score, right? So equal to, I don't like that. I'm gonna change the name, make it more clear, make it more clear. Okay, and we divide it by the cost per score. Okay, and then let's print that out. Okay. And so one thing we have to remember here is that, again, following the rules that we've specified, we do not want an infinite game, right? And in a scenario where both sides are shooting 100%, and obviously where it's an even number of seconds, minutes, everything is even, the same amount of time is going to be spent to score on either side. Because they're both doing the same thing, you're going to end up with an infinite game. You're going to end up with a game that runs forever. So to help resolve that, we have to remove one possession from the total possession count. So one possession is just going to fail, right? And that's just part of the rules. There's just no ifs, ands, or buts about it, right? Again, part of what I'm trying to do here is not have it, again, not have an infinite game, because we know the answer there, right? So barring the infinite game, this is how we proceed. Okay, so let's run this now. And running it, we can see that the cost per score, let's start with 0.3 seconds. Actually, let's go with 2 seconds. So if you spend 2 seconds for every single possession, you would have 1,439 possessions, right? So there we go. Let's put it up here. So now that we know how many possessions are within the game based on the cost of each possession, the next thing we need to figure out is what the total number of possessions are gonna exist that are associated with the first set of points that get scored. And these are the points that are going to include and ones, right? But not include any technical fouls. So to do that, we need to understand how many fouls there are all in all for each team. And then basically figure it out from there. So since these values are not don't change, they're not variable, I'm also going to make them as constants. Okay, so okay, so what I need to know is I need to know the total number of fouls per team, right? So and we're going to calculate that by looking at the number of roster players minus number of playing players. Number of roster players per team. Number of playing players per team. Got to use the same kinds of names, right? So that's going to tell us, again, because we're trying to figure out how many fouls are, we're trying to figure out the number of fouls that are tied to the first period, the regular fouling period. So we'll basically calculate that by figuring out how many players on your team are going to foul, right? Before you hit that boundary, okay? And then we multiply that by the number of fouls per player, okay? So this is gonna give us the number of fouls per team to get to the 10 that need to play, right? But from that 10 that need to play, based on my algorithm, there are still 10 additional fouls, right, between the two players that need to be added to that equation. So to calculate that, we would then add the fouls for those players. So for this particular team, I now add my 5th player, or one of my 5 players that's going to be a designated fouler. I'd have to add their 5 fouls, or their total number of fouls minus 1, right? So number of fouls per player minus 1, right? So whatever the number of fouls are per player, where you hit the limit, before you start getting technical fouls, that's what that will be. Well, total fouls per team. Yes. So over here, number of playing per team. No, rename. Number of roster players. Number of, let's call it active players. I'm just, number of active players, number of roster players, rename per team. Okay. So number of roster players per team, number of active players per team. Okay. It's important to name these properly so that we don't get confused later on. Okay. And now we just need to multiply this by the number of teams, right? So const game is equal to total fouls per team times number of teams. There we go. We have that. And I'm going to change these to lowercase I, so that we have consistency. Okay. So we now have the total fouls in game. And let's go ahead and let's print that out. So go up here. Okay. Total fouls in game. And we're just, all this stuff out here is just, just metadata, because it's only going to print once. right? So, okay, it's really not useful for anything, but it's good to have that list so as a reference point. Okay, all right. So for example, since we know the seconds in game, and we basically are getting our possessions from it, where we're entering the cost per possession, or cost per second. We can kind of see and understand the relationship and calculate that. So now that we have the points per score, let's go ahead and let's figure out what the total cost of this is going to be, like how many points that we're going to be getting from this period of time when there's fouls, right? So over here we can say points during standard period. Move this down a bit. Take this out, put it up here. Take this and put it here where it belongs to this section. Here we go. And how do we calculate this? The points during the standard period, right? So each foul that happens corresponds to one possession, because each foul that happens is going to be an and one. So we can assume that the total number of fouls is going to equal to the total number of possessions, right? So we can then, based on that, we can then just treat the total number of fouls as the total number of possessions, and basically say total fouls right, times the points per score. Okay. So what's happening here? Well, again, in my algorithm, I'm going to take all my files, and I'm just going to commit them all at once and go through all the files that are going to be in the game are going to be committed one after the other. Regardless of how you do it, you're going to get to a point where you're basically getting, because you're hitting 100% and these are all and ones, you're essentially going to, every single time there's a foul, every foul equates to a point, or whatever your point per score is, whether it's a 2-pointer or a 3-pointer, right? So every single foul is going to be those points, right? Plus the additional points associated with it being a foul, right? Which in this case would be 1, right? So they're not doing technical fouls, right? And by 1, what that ultimately means is that the total fouls in the game, right? Okay. And we'll make it more explicit by adding 1. That way we can turn this into a variable at some point if you want to see how it is with adding technical files or whatever. I mean, the answer, and if you insert infinity into this calculation, the final answer is going to be infinity. Spoiler alert, right? So this now gives us all the points that are scored during the standard period, which is the period when you can foul, right? So let's print that out. So Okay, and then points during standard period. Okay, and that takes care of that. And now that we have the points that are scored during the standard period, let's now look at the points that will be scored during the loophole period when basically we're going to be having an additional technical foul, right? So it's not as simple as just calculating the same thing because we first of all have to subtract all those possessions, right? So now, so loophole. Right, so the number of possessions during the loophole period would be the total possessions in game, possessions in game minus the total fouls. Okay. So why are we subtracting the total fouls from that? Because the total fouls in the game also correspond to the total number of possessions that are associated with the standard period, right? So it's the same value, right? You can look at them as synonymous. Right? Now let's print that out. And then loophole period possessions, right? Okay, so now that we have that, we can now then calculate the points scored during the loophole period, okay? And then these points would obviously add that additional value, right? So the points scored during loophole period would be the loophole period possessions times points per possession. I like points per possession better. So I'm going to change that. Plus, as we did here, we take this loophole period possessions, all the possessions, right? And we multiply them by the number of free points we're going to get for that possession. And in this case, it's 2. 1 for the foul itself, because these are still and ones, and 1 for the associated technical foul, right? So 2. And then we can print that out. Okay. So points during loophole period. All right. And then we're essentially done. We just have to add those 2 points together, the standard period points and the loophole period points, and that's going to give us our final set of points. The total points per game would be the points during standard period plus points during loophole period. And then we can just print that out. Not the final, The total points per game. And then I'm just gonna give it some space. And maybe over here, give a little underline section. Okay, so we should be all set. So let's run this, and we're gonna run it and look at what the scores would be for the three scenarios that we discussed, right? The first of them being, okay, a catch and shoot standard three-pointer, right? Which, takes 2.3 seconds to take off, 0.3 seconds to catch and shoot it, and about 2 seconds for the three-pointer to actually go into the hoop. And then medium range jumper, which takes 1.3 seconds and only yields 2 points, and a tip in, which takes 0.1 seconds total, and yields 2 points. So let's run this, see what happens. Okay, so as you can see, we have the total game time. That's how long it is, 2,880 seconds. Total fouls, 130. Cost and time per second. So we'll start with the three-pointer. So that's 2.3 seconds. And we can see that the total possessions for that game is 1,251. And then the points gained for each score is 3. And for that algorithm, the total game points would be 6,125.87. Okay, and we'll play around with that in a second to try to remove all the decimals from it. Matter of fact, let's just do it now. Stop it. And really all we need to do is math that round. And this should convert it into an integer, and this should stop that. So if we run it again, 2.3, 3, and there you have it, right? So 6,125 points is what you would score if you were to do catch and shoot shots and you were from the Pleasantville basketball team. You made everything. That's the most points that can be scored. Okay, so now let's do the two-pointer. And so the medium range two-pointer. So you have 1.3 seconds, right? So the same catch and shoot applies, and then basically it takes about a second for the ball to go in. So you have a bunch more possessions, but then on the flip side, you're only gaining 2 points per possession, right? So if you go that route, catch and shoot twos, your game goes up. You're still gonna win, right? You're still gonna win, and yeah, you're still basically gonna win. Basically, you have way more possessions. So even though you're shooting twos versus threes, you're taking a lot of twos, right? So when I say you're still gonna win, I don't mean that you're gonna win the game. I mean that that algorithm, if you got all 10 players to cooperate with that algorithm would beat the 3-point version of it. Okay. And then the final, and I think you can already see the results here. The final is just tip-ins, right? So for just tip-ins, the cost would be 0.1 second. So you have 10 possessions per second that you get, right? And so you have about 28,799 possessions. Remember that the possessions subtract one because we want the game to end. We don't want it to go into overtime. And the points gained possession by per possession is also two. And so, final answer: if you if you use the tip-in method, right, and you hit 100% of the time, the total number of points that could be scored in the game, given this algorithm. Again, remember that there's caveats to it associated with technical fouls and whatnot that basically make an NBA game have no upward bound in how much what the score can be. But given the constraint that there are no technical fouls and that it does not go into overtime because the game ends in a normal fashion and the shooters, right, make all their shots, right, there are 115,066 points available in an NBA game, right? So that's been a quick example of doing some analytics on data using a rule set that we can pull from the NBA rule set, using common rules that everyone should be aware of. And this is basically at a very small level, the general approach to data analytics. It gets obviously more sophisticated, but this is a simple example that if you don't know anything about the stock market or whatever, you can easily go look up the rules of the NBA, get a sense of it, and then try to build your own model to see if you can beat my number. My number again is 115,066. If there's a rule that I haven't thought of, please go ahead and respond in the comments. Let me know. It's collaborative. If you'd like to create your own version, create that version, send it over to me in your language, and I'll post it and share it. I hope you enjoyed this quick, fun, light video thought experiment. As always, if you like the content that you get here, like it and subscribe, and have a blessed and pleasant day.